Welcome to AI Frontiers, where we explore the cutting edge of artificial intelligence research. Today we're diving into 11 groundbreaking papers from July 9, 2025, that are breaking the boundaries of intelligence itself. From AI safety paradoxes to autonomous discovery systems, from multimodal intelligence to multi-agent coordination, these are just incremental improvements. These are mathematical proofs and discoveries that challenge our fundamental assumptions about what intelligent systems can do and how we can control them. The future of AI is being written right now, and today we'll explore how these breakthrough discoveries are reshaping our understanding of artificial intelligence. Picture this reality check. Right now, as you're listening to this podcast, there's an AI system somewhere conducting PhD-level research independently, designing its own experiments and drawing conclusions that could reshape our understanding of the universe. Meanwhile, another AI is translating foreign films by actually watching the movies, using visual context to improve accuracy beyond what text-only systems could achieve. And perhaps most unsettling, researchers have just provided mathematical proof that some of our most trusted methods for keeping AI systems safe might be fundamentally impossible to implement. This isn't science fiction anymore. The boundaries between what we thought was possible and what's actually happening are blurring faster than ever before, and we're witnessing the emergence of capabilities that challenge our basic assumptions about artificial intelligence. These 11 papers represent something extraordinary in AI research. They're the kind of discoveries that make researchers sit up and say, wait, did we just change everything? We're moving beyond incremental improvements to paradigm shifts that could fundamentally alter how we think about intelligent systems. From autonomous scientific discovery systems that can conduct research at a PhD level, to mathematical proofs that challenge our core assumptions about AI safety, to multimodal systems that can see and understand context like never before. These represent some of the most significant advances in artificial intelligence research this year, and they're pointing toward a future where AI capabilities are expanding in ways that both excite and concern the research community. To understand the significance of these discoveries, think of the computer science artificial intelligence research field like a vast, rapidly expanding metropolis. The downtown core houses researchers working on fundamental theories of intelligence and reasoning, developing the mathematical foundations that underpin everything else. The industrial district buzzes with teams focused on practical applications like robotics and autonomous systems that can operate in the real world. The creative quarter is alive with work on language models and multimodal AI that can understand both text and images simultaneously. And then there's the security district, where researchers grapple with the increasingly complex challenge of making sure all these powerful systems remain safe and aligned with human values. What makes this field particularly fascinating is how quickly the landscape changes. Researchers often joke that a paper published 6 months ago might as well be from the Stone Age, but this rapid evolution also brings unprecedented challenges as the stakes continue to rise. The first major theme emerging from these papers is what we might call the safety paradox. As AI systems become more powerful and capable, our ability to control them through traditional safety mechanisms may actually be decreasing. This isn't just theoretical anymore. Ball and colleagues have provided rigorous mathematical proof that some of our most trusted safety mechanisms might be computationally impossible to implement effectively. It's like discovering that the locks we've been using to secure our most valuable possessions can be picked by anyone with sufficient computational power, and there's fundamentally no way to make them truly secure. The more capable these systems become, the harder it becomes to ensure they remain under human control. This represents a fundamental challenge to how we think about AI safety, suggesting that external control mechanisms may have inherent limitations that we're only beginning to understand. The second major theme is the rise of multimodal intelligence that's revolutionizing how AI systems understand and interact with the world. Traditional AI systems were like specialists who could only speak one language, whether that was text, images, or audio. But the new generation of systems are becoming polyglots that can seamlessly integrate information from multiple sources simultaneously. Liu and colleagues have demonstrated this beautifully with their ViDove translation system, which doesn't just translate words but actually watches videos to understand context, achieving a remarkable 28% improvement in translation quality. Imagine having a translator who not only speaks both languages fluently, but also understands the cultural context, the visual cues, and the subtle implications that come from seeing what's actually happening in the scene. This represents a fundamental shift from single-modality AI to systems that can process and integrate multiple types of information just like humans do naturally. The third theme involves AI systems that can plan and coordinate complex multi-step tasks through sophisticated multi-agent orchestration. This goes far beyond simple task completion to systems that can orchestrate dozens of specialized agents working together on complex problems. Kumar's work on multi-robot path planning and Zhu's autonomous scientific discovery system both demonstrate this capability beautifully. It's like watching a master conductor lead a symphony orchestra, where each musician has their own specialized part to play, but the conductor ensures they all work together harmoniously to create something coherent and beautiful. These systems can break down complex challenges into manageable components, assign different aspects to specialized agents, and coordinate their efforts to achieve goals that would be impossible for any single agent to accomplish alone. This represents a major step toward AI systems that can handle the kind of complex, multifaceted challenges that characterize real-world problem-solving. Let me share some of the most significant breakthrough stories from this collection of papers. Ball and colleagues discovered that malicious prompts designed to make AI systems behave badly can be crafted to look identical to innocent prompts, at least as far as any practical filtering system is concerned. Liu and colleagues achieved a 28% improvement in translation quality by giving AI systems the ability to see visual context, not just read text. Zhu and colleagues created an AI systems that can conduct independent scientific research at a PhD level, successfully measuring cosmological parameters using supernova data by orchestrating about 30 specialized AI agents working together like a research team. Du and colleagues developed systematic approaches for creating high-quality instruction datasets, focusing on both coverage and depth to ensure AI systems can learn to follow instruction across diverse tasks, while developing deep expertise in specific domains. Anders and colleagues proved that reasoning systems based on counterexamples are strictly more powerful than those based on contradictions alone, providing crucial insights into how we can build AI systems that can engage in sophisticated reasoning and change their context when no systems. With the operating team, today's paper of the day is on the impossibility of separating intelligence from judgment by Ball, Chevlain, and Irving. This isn't just another technical paper about AI safety. It's a fundamental challenge to how we think about controlling powerful AI systems. The authors investigated whether we can make AI systems safe by filtering their inputs and outputs, an approach that many researchers and companies have been counting on as AI systems become more powerful. Using techniques from computational complexity theory and cryptography, they discovered something deeply unsettling for anyone counting on filtering as a safety mechanism. They proved mathematically that there exist large language models for which no efficient prompt filters can be constructed. This means adversarial prompts can be crafted to be computationally indistinguishable from benign prompts for any practical filtering system. It's like proving that there's no efficient way to tell the difference between a genuine $20 bill and a perfect counterfeit, even with unlimited computational resources. The technical breakthrough goes even deeper. The authors show that output filtering can also be computationally intractable under certain natural conditions. Even if we can't filter inputs effectively, we can't necessarily rely on filtering outputs either. The computational requirements for reliable output filtering can exceed what's practically feasible, even for systems with substantial computational resources. What makes this work particularly compelling is how the authors connect their technical results to broader philosophical questions about the nature of intelligence itself. They argue that their findings demonstrate the fundamental impossibility of separating intelligence from judgment in AI systems. You can't have a system that's intelligent enough to be useful without also having the capacity for judgment, and that capacity necessarily includes the ability to make judgments that humans might consider harmful. This represents a perfect counterfeit scenario, where malicious and benign prompts become indistinguishable, making traditional safety approaches fundamentally inadequate. The implications of this research extend far beyond technical details of filtering algorithms. If Ball and colleagues are correct, then many current approaches to AI safety may be fundamentally flawed. The idea that we can build powerful AI systems and then make them safe by adding external controls may be based on a false premise. Instead, safety may need to be built into the core architecture and trading process from the very beginning. This has important implications for AI governance and regulation, as many proposed regulatory frameworks assume that AI systems can be made safe through external oversight and control mechanisms. If external safety mechanisms have fundamental limitations, then the responsibility for AI safety may rest more heavily on developers themselves. This could lead to significant changes in how AI research is conducted and how companies approach the development of new systems. The very intelligence that makes these systems useful may also make them impossible to control through external means. Looking toward the future, the research landscape revealed in these papers suggests several promising directions that could reshape artificial intelligence in the coming years. Think of the current state of AI research like a river that's been flowing in multiple channels, and we're now seeing those channels begin to converge into a more powerful, unified stream. The success of multimodal approaches suggests that the future belongs to AI systems that can seamlessly integrate information from multiple sources, just as humans naturally combine what they see, hear, and read. The emergence of sophisticated multi-agent systems points toward a future where AI can orchestrate complex multi-step projects requiring coordination between different types of expertise. Theoretical advances in understanding reasoning and argumentation suggest that future AI systems will be better at engaging in nuanced, context-dependent reasoning. However, the safety challenges revealed by this research also point toward a future where AI development must be approached with much greater caution, with safety as a core consideration from the very beginning rather than an afterthought. As we wrap up today's journey through the frontiers of AI research, let's appreciate the remarkable scope of what we've explored. We've seen mathematical proofs that challenge our fundamental assumptions about AI safety, AI systems that can conduct independent scientific research, and translation systems that can see as well as read. We've witnessed the emergence of sophisticated multi-agent systems that can coordinate complex tasks and theoretical advances that deepen our understanding of reasoning itself. These aren't just incremental improvements to existing technology. They represent fundamental shifts in how we think about artificial intelligence and its role in society. The AI systems of tomorrow won't just be tools that we use. They'll be partners that can see, reason, discover, and create alongside us. But as Ball and colleagues have showed us, this future also comes with new challenges that we're only beginning to understand. The research we've discussed today is freely available for anyone to read and build upon, and your voice matters in shaping where this conversation goes next. This research synthesis was created using advanced AI systems, including GPT, Anthropic, CLAUDE-SONNET-4-20250514 for content analysis, DeepRAM technology for TTS synthesis, and OpenEye systems for image generation. The synthesized content underwent human expert review to ensure accuracy and clarity. While we strive for precision in presenting these complex research findings, some oversights may exist, and we encourage listeners to consult the original papers for complete technical details. All referenced papers are freely available through the archive preprint server, and we provide direct links to the original research in our show notes. This approach allows us to bring you cutting-edge research insights while maintaining transparency about our synthesis process and acknowledging the collaborative nature of modern AI-assisted research communication. Subscribe to AI Frontiers for weekly deep dives into breakthrough discoveries that are shaping the future of artificial intelligence. Join our community of researchers, developers, and tech enthusiasts who are passionate about staying ahead of the curve in AI research. Share your thoughts on these discoveries, engage in the conversation about AI's future, and help shape the direction of this rapidly evolving field. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this is upload print server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by Archive Preprint Server.